All right, guys, so for this one, we're getting into equation solving. We're going to start, if you see here, I'm on J.3 for IXL with one-step equations. However, we'll quickly kind of back out and go to multi-step equations and equations that have variables on each side of the equal sign as well. So just kind of a how-to as we move forward in algebra. Okay, so let's start by kind of talking the concept. The way I usually describe this to my students is to think about us when we're solving for a variable, getting a final answer that's a three-part answer. So when I say three parts, what I'm looking for is a variable. So that's kind of what they have here with R. Let me see if I can circle that. The equal sign, and then whatever it equals. That's the blank that they give you. So that's what our goal is. It's not just the number, but it's all three pieces there. The reason we have to be specific with that is in the future, you'll eventually encounter equations that have more than one variable, so you'll need to specify. It's also possible to have inequalities, so it might not be equal to, it might be greater than or less than, greater than or equal to, or less than or equal to, something like that. To get started, I usually ask the students to think about undoing the order of operations when we're getting a variable by itself. So think about like PEMDAS, usually starting with addition and subtraction. So like those two, and then working multiplication and division, and then exponents, then parentheses. So kind of going through in reverse. And for this specific problem, anytime you have a coefficient like the 2 next to a variable like this, remember that means multiplication equals, oops, not 20, equals 10. I did the same thing again. 2 times R equals 10. There we go. Don't know why I was struggling with that there. But if we're thinking about PEMDAS and going through it in reverse, I would look for addition and subtraction first. However, I don't have any that's attached on the left-hand side here, so I would move over to multiplication and division. Currently, my variable is being multiplied by 2, so I need to think to myself what undoes multiplication, and that would be division. So I'm going to divide on both sides of this equal sign, and whatever I divide by on one side, I got to do on the other. I'm going to divide each side by 2. The reason I want to divide each side by 2 is because I want these 2's to cancel each other, leaving just the R. That way I have my three-step answer like R equals. So those are going to cancel. The reason they cancel is anytime you multiply and divide by the same number, it would go to 1. Multiplying that R by 1 doesn't really do anything. So then I would be left with R. I still have the equal sign. 10 divided by 2 would give me 5. So let's show that here. There we go. All right, so we'll clear off. Let's do one more, and then we'll move to J4, I think. So I have 16 equals D plus 4. Line down the middle. I like to do that because it shows my two distinct sides of the equation, left-hand side, right-hand side. Thinking backwards through PEMDAS, addition and subtraction is what I'm looking for. I do have addition here, so I want to think what undoes addition. That's going to be subtraction. I'm going to subtract that number, that way they cancel. These things cancel because adding and subtracting the same number would give you 0, and D plus 0 doesn't change what D is at all. So then I would have D, an equal sign, and 16 minus 4 would give me 12. So once I have D equals 12, I'd type that in, and that's all the parts here. Okay, so I'm going to clear, and then I'm going to go to J.4. Let's go back to Algebra 1 for a second here. If you notice when we get here, we have J5 as the one that my class is doing. I think if you see what's going on in J4, J5's fine. You're just putting more pieces together. This actually has a similar strategy, but we'll kind of talk through it. So I have 15 equals 4 s plus 3. If you notice in the title of this one, it's two-step equations, meaning we got to get rid of both that 4 and the 3. Use the same strategy we just talked about where I'm undoing PEMDAS. So I'm getting rid of any addition or subtraction first. So I'm going to get rid of this first. Got to do the same thing to the other side. So now I have 4s left over equals, this would be 12. If you notice, I don't have my answer though, because I don't just have s equals. I need to get s by itself. So remember that anytime that the coefficient, the 4, and the variable are next to each other, that's multiplication. So I'm going to divide both sides by 4. And I'll write it off to the side. I'm going to get s equals 12 divided by 4 would give me 3. Plug that in. Excellent. Let's look at one more, and then we'll move forward again. 19 equals b over 3 plus 17. Same thing as before. I want to get rid of the 17 first because it's being added on. So I have b divided by 3 left over equals 19 minus 17 would give me 2. Now this is a little different. B is being divided by 3, so to undo division, I'm going to multiply on both sides and get b equals 6 when I do that. So just 2 steps here, same idea, but we just have to keep track of what thing to do first. Okay, let's go back to Algebra 1. Scroll back down, and we'll look at J5. So this is the one that's actually assigned to my Algebra 1 classes, called Advanced, solving advanced linear equations. So that's just kind of tying in multiple steps here. The book calls this just multi-step equation solving. So let's write out. This is an example of an IXL where not every problem's the same, but if you understand the concept, it shouldn't be too difficult. But like we just said, you have to understand that concept. Okay, so same strategy as before, trying to undo addition and subtraction first. I have that here, but it's inside parentheses. So since parentheses would come last in this, I'm actually going to get rid of this 2 first. To get rid of the 2, a common strategy that most like Algebra 1 students would do is to distribute first and then start undoing, because you learn distribution around this time. But got to remember that that 2 on the outside is just multiplication. So to do this all in one step, you could actually just divide everything by that outside number. When I do that, I'm going to have z plus -1 equals 0 divided by 2 is still 0. Now I have z plus -1. I'm going to rewrite that as z minus 1. That's the same thing. And then here I'll go up top. Z minus 1 equals 0. I would add 1 to both sides to solve that. And I'd get z equals 0 plus 1 is 1 here. Remember, you can check by plugging in whatever value you get back into the variable. So if I plug in 1 here, 1 plus -1 is 0. 2 times 0 would equal 0. So that checks out. Awesome. Let's go through another one. Something like this. I have g, a bunch of 2's in this one, plus 2 divided by 2 equals 2. Now, I have addition here, but when it's all on the top of a fraction or a ratio, division, however you want to think about it, it's treated like it's in parentheses. It's grouped together as that numerator. So it's going to be after we get rid of this 2 on bottom first. So we're multiplying both sides. Then I would just have g plus 2 left, and there wouldn't be parentheses now that it's the only thing. Equals, this is going to turn into 4. Now I can subtract 2 on both sides and get g equals 4 minus 2 is 2. Okay, look, our answer is even 2. That makes sense too when I plug it in. 2 plus 2 is 4. Divided by 2 does give me 2. All right. Let's jump ahead a little bit, see if there's anything that really throws us. Oh, now we're in the 70s range. Let's look at something like this. I have a minus a plus a, seems redundant, plus 2 equals 17. My suggestion is anytime you have multiple variables or multiple constants on the same side of the equation, group those all together by combining like terms. So all these a's are going to go together. So think about 1a minus a would take me to 0, but plus another one would take me to just 1a. So those are going to combine to 1a, and then I still have the plus 2 and the equals 17. So we combine those. We can still subtract 2 from both sides and get a by itself equals 15. So as long as you know how to combine like terms, this one wasn't too bad. A lot of the, well, 2 of the 3 a's are going to cancel each other out. Super. All right. Now let's go to J .6, and that'll be the last one we look at for this video. Kind of while I'm changing gears here, just a reminder, if you could, if you feel like it, I suppose, if you found this helpful, give it a like, subscribe if you want to make sure you actually see all these videos. If you're in my class especially, ring the bell, get notified. That would be helpful. Okay, going on to J6, the difference here is that there's going to be variables on both sides of an equation. So I have negative z minus 6 equals negative 2 times z. So z is on both sides here. The main thing to do here is to put all things with a variable on one side of the equation and all things that are constants, meaning without a variable, on the other side. Doesn't matter really which one. Sometimes one will be easier than the other, but both will give you answers that are correct. For me, I'm going to move all the z's to the left-hand side. That's my personal preference because at the end, I like having my answer set up with the variable on the left. If you wanted to do it the other way, that's totally fine. But to move this z term over, because it's a minus 2z, I need to add 2z. That z looks a little weird. Something like that. It's going to cancel, but when we add it over here, we'll kind of see what's going on. Equals, well, if they cancel, I just have 0 left. And then negative 1z plus 2z is going to give me just a z, or 1z, minus 6. Then this looks like something we've been dealing with where I can add 6 to both sides and get z equals 0 plus 6 is 6. Okay, let's look at another one. Let's jump ahead a little bit, and then this will be the last problem, I think. Let's go with this one. So I have 10 plus 5 times h equals h minus 10. I'm going to try to get all my constants to the right and variables to the left. Like I mentioned before, that's just my personal preference. You could do it the other way. I'm going to subtract 10 so that I don't have constants on the left side anymore. I'm going to have 5h still equals h, and then negative 10 minus 10 would give me negative 20. Now I want to move the remaining h on the right side to the left side. Because it's a positive h, I'm going to subtract h from both sides. And now I'll just have that negative 20 equals, this is now going to be 4h. Now I have one step of division, and I'll have h equals negative 5 is what we end up getting on the right-hand side there. So let's plug that in. Let's double check. Awesome. Okay, so we'll wrap up there. Like I said, reminder, hopefully this was helpful. Like it, subscribe if you feel like it. See you.